In this video, we'll be looking at two sample problems in modular arithmetic. So the first one is going to be a system of equations that requires integral solutions. So let's take this system. We'll have 3a plus 5b equals 8, and we'll have 3a plus b equals 2. And we want to find if this has any integer solutions. Okay, so it definitely has regular solutions, because if we just do this, we have 4b equals 6, so b equals 3 over 2, and then you can solve for a. But that's not what we're worried about. We're worried about only integer solutions. So let's write this in a different form. This 5b and this 8 we can break up. We can write that as 3b plus 2b equals 3 times 2 plus 2. And this we can leave as it is because we can't split this into any further 3's. So let's analyze this top equation right here. So we'll write this one back later. So this top equation, you see that this is a factor of 3 right here, and this is a factor of 3. So the remainders, this and this, if these are integers, so if a and b are integers, that means the remainders have to be equal. So 2b has to be congruent to 2 mod 3. To see what that means, if we divide this whole thing by 3, we get a plus b plus 2b over 3, and then here we get 2 plus 2 over 3. So that means the remainder has to be 2 in both cases. Not necessarily 2, but it has to be equal to 2 mod 3. So it could be 5, it could be 8, and so on. So the point is, we have this equality right here. 2b is congruent to 2 mod 3. And that reduces to b is congruent to 1 mod 3. So we'll keep that piece of information right here. Now we'll go back to the second equation, which said 3a plus b equals 2. And then here, using the same logic, if we divide this all by 3, we get a plus b over 2 is, by 3 is 2 over 3. So that means that the remainder has to be 2 mod 3 in this case. And the remainder here is just b, not 2b. So that means that b is congruent to 2 mod 3. So now we have two statements right here. We have b is congruent to 2 mod 3 and b is congruent to 1 mod 3. And then since they can't both be true, it can't have a remainder of 1 and 2. We see that this has no integer solutions. So in this case, it might have been, this is definitely faster if you do it this way. So that's basically how you do those kind of system of equation that way. And then the second problem we'll do is an application of the multiplication law for the mods. So we're going to say we have 44 crates of something, you could say soda. So 44 crates of soda. And for some reason there's 113 cans per crate. So the packager wants to take all the soda, all the cans, and put them into 12 cans per crate to make it more manageable. So how many will he have left over when he puts 12 cans per crate? So we could do it. We could multiply these two figures and then divide by 12, find the remainder. But there's an easier way. We can just we can say that 44 is congruent to what mod 12. So we see that that's going to be 8 because this is 36 and then we have 8 left over. And this is congruent to what mod 12. So we see that that's going to be 5 because if we have 12 and we multiply it by, it's probably going to be 9. You have 18, 108, and then you have 5 left. So we see that those are true. Now if we just multiply these two, you're allowed to multiply these two by the multiplication law we learned in the last video. So 113 times 44, which is the total cans of soda, is congruent to 40, which is congruent to just 4, since you can take 36 out, mod 12. So you see the remainder is going to be 4. So these are two basic problems using applications of mods. So hopefully that helped see how mods are important.